Hello, student. Very good evening to all of you. Very good afternoon. Start. Hello, student. Very good evening to all of you. Good afternoon, good evening, and good morning. Whatever your time watching, whatever time is suitable for you, and that way I am listening. Okay. So, hope you are doing well, doing great by health, wealth, and success. So, it is going on the series of periodic table. We are here with the next lecture. In previous session, previous lecture, we have studied about the history of the generation of periodic table, how it was developed. The first scientist was Dob Reiner triad. Means Dob Reiner has given us a triad rule. He has taken three elements simultaneously, and the average masses of that terminal atom gives us the mass of middle atom. He was failed because it was not applicable all the elements. It was failed in same group and same period also. Then who came? Right, you are very right. Then Newland came. He told us that the first element repeats its property at eighth position. Means you can say eighth element repeat its property as first. Means if we put the elements in order, increasing order of atomic weight, then we see the physical and chemical properties of first element is just similar to the eighth element. That was octave rule. Why it was octave? Because he was music lover. According to the Indian music note, the eighth note repeat itself as sa re ga ma pa dha ni sa. Sa repeat again. So it was the octave rule. He somehow able to classify till 20 elements, and he was also failed. Why he failed? Because that time noble gases were not known. After some time, when the discovery of novel gases occurred, he also failed. But he was quite successful because first time a scientist has came who has classified element in horizontal row and vertical column. He don't tell us that this is group or period. Group and period was told by Mendeleev. When he was failed, then Mendeleev has come. Mendeleev has classified almost all elements that time were known. Almost 63 elements known that time. He has classified all the elements in group and period. He told us the vertical column is known as groups and the horizontal row is known as period. But there was some defect also in his periodic table, so he was also failed. Now it is the turn of modern periodic table. Modern periodic table has discovered by Moseley. Moseley was a fabulous scientist. He has done an experiment like he bombarded X-rays on the atoms and he noticed frequencies. According to the frequency, he had he had concluded that all the physical and chemical property of an element is depend on atomic number. So here are all the confusion, all the defects finished. So let get start from the modern periodic table. Modern periodic table basically it was it was depend on atomic number. What is that? There is some problem. It was based on. Why is this happening? There is some problem. Now it is sorted out. Okay, where we were talking about modern periodic table. So so basically here modern periodic table was based on atomic number. Atomic number. means the physical and chemical properties of elements are periodic function of atomic number. When Moseley bombarded X-rays on the atoms, then emitted frequencies he noticed, and he concluded that all the while it is chemical properties, while it is physical properties, all the based on the atomic number. So this is the main achievement. Now these days also it is told that the all physical and chemical properties are derived from the atomic number. So atomic number is the most important properties. So it was the defect of, as you know, it was the defect of the Mendeleev periodic table, Newland octave rules, and Dov Reiner also failed because they all were doing the classification on the increasing order of atomic weight, but he has done on the basis of increasing order of atomic number. So it was too good. So let's see modern periodic table. In modern periodic table, there are lots of sections. So first of all, we will discuss on section, and then we will discuss on the properties. There are some defect also in the modern periodic table too nowadays, but they are not so effective. Means so. Let's see modern periodic table first. This is the modern periodic table. As you see, in modern periodic table, there are 7 period. These are period 1, 2, 3, 4, 5, 6, 7. The horizontal rows are known as period. There are 7 period, and there are vertical columns. Vertical columns are known as group. There are 18 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There is some mistake. 12. So there is mistake. This is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There is mistake in the periodic table. 1, 2, from 3 to 12 there should be, and from 13 to numbering are wrong here. 13, 14, 15, 16, 17, and 18. Actually, there are some elements are repeated. So you can see here there is some misprint. But as I am telling that there are 18 groups. Look at here. There are 7 period. Horizontal rows are known as period, and vertical column there are 18 column which are known as groups. Now, according to the block, if we see, there is S block, there is P block, and there is D block, and there is A block. These last 2 rows are known as A block. So why are they are known as SPDF block? If we know the electronic configuration, we will learn also the electronic configuration. There I will tell you that the last electron goes into the valence electron. The valence electron is goes into the last cell, and that cell is if S, then the element comes into the S block. According to the last cell, we decide that it is the element of that particular block. Okay. So, what is more about this periodic table? There is block, and also the first group. Look at here. This is the first group. First group is known as a group of alkali metal. These are alkali metal. Okay. Now second group are known as alkaline earth metal. These are the S block element. And in S block element there are two group. One group is known as alkali metal and second group is known as alkali earth metal. All the elements of D block, look at here, from here to here, these are D block elements. In D block elements, except zinc, CdHg, these three elements are not known as transition elements. All elements of the D block are known as transition metal. Transition metal. What that mean? Transition metal. Transition metal means if there is unpaired electron inside d orbital. If we configure the element, then we see in d orbital. What is orbital? Let's see first about orbital. If we'll talk about scandium, so we are going to start from scandium to zinc. Then how it will decide? You will going to know that zinc is not tungsten metal, and all the metals are here are tungsten metal. So let's distinguish between tungsten and non-tungsten metal. Okay, let's get started. Let's take one page, one blank page. Here is. So look at here. In D block, especially, there are three type of series. D block elements. There are three type of series. First is 3D series. The elements are 3D series of is scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. Okay. So the atomic number of element, if you don't know the atomic number, it is very easy to learn. Start from here. Scandium. Scandium is on at 21. From 21, let's start in sequence. 21, 22, 23, 24, 25, 26, 27, 28, 29, and last one is 30. These are the atomic number of elements. These elements. Basically, all the elements of the D block are metals. Do you know about metals? What is metals? You have studied in your earlier classes, in junior classes, that what are metals. Basically, metals are those substances who donate electron. They are ductile. They are malleable. What is the meaning of ductile and malleable? I hope you know, but let's explain a little bit about malleability and ductility. Ductility means something can be drawn into wire. Malleable, sorry, my mistake. I'm really sorry. Ductility means that can be converted into heat. That is ductility property. Means any substance that can be converted into heat is known as ductile. That property is known as ductility. If any metal, any substance can be drawn into wire. Do you know about gold? The 1 gram of gold can be drawn into kilometers. 1 gram, a small quantity. The small quantity of gold can be drawn into kilometers into wire. So that is known as malleability. So gold is so malleable. So we are talking about metals. In D block, there are all metals. All elements are metals. They are ductile, sonorous. They are malleable. As you know, sonorous. There is a specific sound of particular metal. So they are metals basically. So scandium to zinc all are metal, but here are in 3D series. If we see, these all elements are transition metal. But the last one, zinc, is not a transition metal. This is non-transition metal. So how would you decide that these are transition metal and that one is not transition metal? How would you decide? Okay, let's see. The one thing is that is electronic configuration. Do you know how to configure the electronic configuration? Okay, I will teach you. Let's learn. There is a pattern that is known as above principle. Above principle. Above is a German word which means to build up. To build up to put the things in increasing order. To put the subcell in increasing order. And if first of all, the lower energy of the subcell of lower energy will come first, and then higher energy will come later. As let's make above principle. This is a German word. It was not a scientist. Students always think above is a scientist. It is a only word that means to build up. Above is a German word, which means to build up. Okay. So above principle tells us the electronic configuration of element. So look at here how can we configure all these metals. First of all, we have to learn, sorry, above principle. So here 1s, 2s, 2p, 3s, 3p, and 3d, 4s, 4p, 4d, 4f. These are subcell. These subcell are arranged in increasing order. Look at here. This particular subcell has lowest energy, so it has kept as first place. So from here to here, I have to take this particular subcell. First, we'll take 1s, then this will impede. Again, return from this side. What will you get? 2s. Now again, this path will empty and return by this side. What will you get? 2p and 3s. 2p and 3s. Look at here. As you are returning, this darker line will hit at that particular cell that you will keep here. Okay. Now again, the third line will be empty and return with by this way. You will get 3p and 4s. 3p and 4s. Again, this will empty and you will see here you will get 3d and 4p. 3d. Okay. So it is larger than this, but by this particular sequence we can configure all these metals. So we will use it. We will discard here. If we will study structure of atom, then we will discuss about this particular principle in details. Okay. So let's just start about electronic configuration of scandium to zinc. So learn it. You have to learn it. Without remembering, it is not possible to configure it. So I erase it and start from the scandium. So this is 1s, 2s, 2p, 3s, 3p, 4s, 3d. Now, how much electron will be there in particular cell? Look at here. S, P, D and F. S has 1 orbital, P has 3 orbital and D has 5 orbital. D has 5 orbital, 1, 2, 3, 5. F has 7 orbital, 1, 2, 3, 4, 5 and 6 and 7. How will you learn? Look at it. There is 1, there is 3, there is 5, and there is 7. There is two gap. There is 2 digit gap between orbital. S has one orbital. Add 2, 1. If you add 1, 2 in 1, you will get 3. If you add 3, 2 in 3, you will get 5, and so on. So there is only two digit difference. So what that meant of, look at here. If we fill the electrons in orbital, look at here, there is 2 electron. Means in S subcell there would be 2 electron. In P there is 2, 4 to 6. There is 6 electron. 2, 4, 6, 8, and 10. There is 10 electron. 1, 2 to 4, 6, 8, 10, 12, and 14 electron. So look at here, there is 4 gap. 2, 4, 6, 6, 4, 10, 10, 4, 14. So in electron there are 4 gap. In orbital there are 2 gap. So overall we are discussing about transition metal. If we know these sequence, if we know the electronic configuration, then we will able to find the transition metal or non-transition metal. Because in d orbital, this particular d orbital, if there is unpaired electron, in d orbital, if there is unpaired electron, then we will say that particular metal is transition metal. If there is no unpaired electron, this is fully filled, we see that particular metal is stable, so it would not come in category of transition metal. It would not be transition metal, it would be non-transition metal. Similar it would happen with zinc. Okay, let's see. Okay, let's see. So in scandium, if we see in scandium, there is, look at here, one more thing can be also possible, that 1s, 2s, 2p, 3s, 3p, 4s, 3d. If we fill electron according to the subcell, so put 2 electron in s, put 2 electron into s, put 6 electron into p, again 2, again 6, again 2, again. Here you can fill how many electrons? In d there can be 10 electrons. Okay, so if we put 10 electrons, now count all the electrons. 2, 2, 4, 6, 2, 2, 4, 6, 10, 12, and 6, 18. Look at here, these are collectively can be written as argon, because the atomic number of argon is 18. So you can write these all the configuration in a abbreviation. So use it, rather than write in the wider form, you can write it into a abbreviation. So this is argon. Till the argon, if you write the argon, you will get 18 electron at once, and after then you use these two subset, only these two subset, 4s and 3d. So we will use in all these metals configuration this one. Okay, so let's get started. Argon 4s 3d, argon 4s and 3d. Put electron s, in s there is 2 electron. In d, how many electrons are there? 1 electron left, because this is 18, 18 and 2, how much? This is 20. How many electrons are left? There is only 1 electron left. So put 1 electron. So this is the electronic configuration of scandium. Similarly, you can write the configuration of titanium, argon and 4s 3d. How many electron you put in s? 2 electron. Add usually 2 electron. How many electron are there in d? There is 2 electron. Look at here, I will tell you a pattern. You can directly put the electron into the subcell without seeing anything. Look at here, in vanadium there is argon and 4s and 3d. In s there is 2 electron, in d there is 3 electron. Okay, look at here, there is two exception that is very important, always asked in examination. Look at here, chromium and copper. These are two exceptions, and there will come one another rule that is known as Hund rule, whatever you can call by spelling. So chromium, about chromium, what is that? Look at here. Chromium atomic number is 24. So we can write it as an argon and 4s 2 electron and 3d can 4 electron. If we write according to the rule as above rule, then it can be written as this. But this was not correct electronic configuration. The electronic configuration of chromium was some different way. What was that? Look at here. Now it will come the turn of that particular orbital. What is orbital? Look at it. There is orbital in S. How many orbitals are there? There is one. In D, there are 5 orbitals. There are 5 orbitals. So this is 1, 2, 3, and 5. Now it is the turn to filling electron. Look at here. Okay. There are 2 electrons. Put here. There are 4 electrons. 1, 2, 3, and 4. Now look at here. If that particular electron jump from here and goes to that particular orbital, then what will happen? Look at here. This particular electron comes in its excited state and jump from here to here. Now look at here. There is only one electron. Now in d orbital there are 5 electrons. There are 5 electrons. 1, 2, 3, 4, 5. What that means? There is another rule that is known as Hund rule. What is Hund rule? He says that if orbital are half filled or fully filled, they are quite stable. That are most stable. If you compare in half filled and full filled, then you will say always that full filled orbital are most stable. Means totally filled orbital, d orbital, if they are d orbital or p orbital, in all cases you will see if full filled orbital are there, they are quite stable. Half filled orbital are there, they are less stable than full filled. But generally half filled d orbital, p orbital are more stable. That is Hund rule. Do you understand? Okay, let one example. Let's take one example. Look at here. This is p orbital. There are 3 orbitals. If there is only one electron are filled, means they are half filled. This is stable. If we take d orbital, there are far yeah sorry. So there are 5 orbitals. If we fill 1, 2, 3, 4, 5, this is half filled. So this is stable. So here look at here. There is one and there is 5 electrons. They both boxes means both orbital are half filled. What that mean? That means it is stable. So this particular configuration is wrong. Now what would be the correct configuration? Here will be 1 electron and here will be 5 electrons. So this is exception according to Hund rule. Okay, always remember it. It would surely asked in your examination. It would surely. Okay. Now come at manganese. Right here, argon 4s and 3d. There is 2 electron in s and there is 5 electron. So look at here. If you will see, there is unpaired electron in the orbital. There is 1 electron that is unpaired. There is 2 electron that is unpaired. There is 3 electron unpaired. There are 5 electron unpaired. So here are unpaired electron. You will configure all elements, then you get from scandium to copper. There are always you will get unpaired electron. That means they are a tungsten metal. If unpaired electron are present, they are known as tungsten metal. If we talk about zinc, then what would happen? Let's see about zinc. Okay, I erase it. Zinc. What is the atomic number of zinc? That is 13. If we write the configuration, that is argon 4s and 3d. Fill the electron and look the magic. There is 2 electron and there is 10 electron. Okay, look at here. There is 18 electron, 18 plus 2 and 10. How much? This would be 30. So this is the electronic configuration. If you will see in d orbital, the d orbital has 5 orbital. D subshell has 5 orbital, 1, 2, 3 and 5. Now fill electrons. If you fill electron, then you will get this. This is fully filled. This is fully filled. So this is quite stable. If electron are fully filled, means d orbital are fully filled. There is no unpaired electron, means it is not transition metal. It is non-transition metal. It can be, it could be the electronic, it could be the transition metal. If we excite one electron and there would be one at least one unpaired electron, it can possible that it could be the transition metal. But even on its excited, it don't have any unpaired electron. Look at here. Suppose that there is two electron. If we excite, zinc can show two variable state. Zinc can show two oxidation state, plus 1 and plus 2. If we excite this particular electron, it would be empty. Even on its ionization state, the d orbital are fully filled. So it is not transition metal in any way. Do you understand? So it was the big concept about d block element, that was transition metal and non-transition metal. So let's come again on the periodic table and talk about d orbital. So basically, we understood here that the d orbital, the d block elements, all metals are not transition metal. Only these metals are. If left, then all the metals are transition metal. Only zinc and cadmium and mercury are not transition metal. Okay, got it? Now it's turn to p block. So these are p block element. In p block element, there are lots of sections and all are known as with the different family name. This is the boron family. Boron family. This is the carbon family. And this is the nitrogen family. Nitrogen family. Remember it. The particular question, whenever asked, they will say always the element belongs to the nitrogen family. So the nitrogen family, that is nitrogen, phosphorus, arsenic, these all elements are known as nitrogen family. The oxygen family is known as chalcogen family. Chalcogen family. And this particular 17 group means fluorochlorobromoido are known as halogen family. These are also known as salt family. These are also known as ore family. And last one is known as, this particular group are known as noble family, noble gas family. These are noble gases. These are rare metal. These are inert elements. These are inert atoms. They do not react. Okay. So this was the particular classification of above periodic table. Now it is the turn of last section, that is F block. These are come from, look at here. In, if you look here, this particular two boxes are empty. They are not empty. They are here. Here is lanthanide and actinide. These two particular series are kept outside the table, and that is the defect of modern periodic table. Actually, modern periodic table should have this particular section has kept outside the table. That is defect. That should be here, but it is not possible to kept here. So it was kept here. Look at here, lanthanide. Lanthanide is the D block element. But if we remove it, these particular two elements, if we remove it, so from here to here, these all elements are known as F block elements. From cerium to lutetium, cerium to lutetium, here one element are left, that is lutetium, and here is one element are left here actually. I don't remember correctly, but one element is are left. Look at here. So these are F block elements. Lanthanide, lanthanide has a specific property that is known as lanthanide contraction. Actinide has a specific property that is known as actinide contraction. We will talk about actinide contraction and lanthanide contraction later. This is another concept. So these are elements and the classification of all elements, all group, all section blocks, which I have explained. So let's move forward and see more things. So it was all about electronic configuration. There is exception in all the section S block, P block or D block. There are exception also. So here we are only talking about the classification. We will not discuss about electronic configuration and that particular exception. I have already told two exceptions, that is chromium and copper. Remember it. The most question has been asked yet from that particular two elements, that chromium and copper. So it was the all about electronic configuration and classification. As you know, look at, this is a rough figure of periodic table. These are S block elements. These are D block element, and these are P block element. These are F block. Okay. So I will talk about a little bit more of this particular table. Look at here. There is alkali metal group, and there is alkali earth metal. If we see, that is hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. If we configure all the elements of group 1, you will get the valence electron, that is 1. What that means? The valence electron is 1 means they show only one oxidation state, that is plus 1. Means they can lose one electron. If any metal, not about metal, if any element lose electron, that means what? That means that is particular metal. So metals are that side. Okay. If we see in group second, that is beryllium, magnesium, calcium, strontium, and radium. If we configure the elements, then we will get the valence electron, that is plus 2. What that means? Means they can donate 2 electrons. They can lose 2 electrons. So they are also our metal. So basically, look at here. These particular two group are more, you can say, most magnetic. Sorry, most, you can say these are most metallic character. Okay. Now move forward. If we go, these are the property. Actually, we will discuss about the properties. There are lots of properties in periodic table, and we will discuss one by one in details. This is a only surface explanation. We will go in detail and depth, as there are lots of properties: atomic size and melting point, boiling point, atomic ionic radii, and ionization enthalpy, electron affinity, electronegativity. There are lots of properties we will discuss about further in detail. Today we are just looking the periodic table, modern periodic table, how is the section are and how they are kept in the periodic table and what is the name of that particular group and period. Okay, so we were talking about that these are S block element and these are particularly falls into the category of metal. They are most metallic character. They have most metallic character. Okay. In D block, if we will see, then all the metals, all the elements are metal. All the metals means all elements are metals. If we go in this particular side, this is P block. Then we'll see in P block there are non-metal. That not means there is not metals. Metals also exist, but mostly they are non-metal. Look at here. This is beryllium, aluminium, gallium, indium, and thulium. Look at here. You know about aluminium is a metal, but boron is non-metal. Carbon is non-metal. Nitrogen is non-metal. Oxygen is non-metal. Fluorine is non-metal. Okay. So these are non-metal. Mostly in this section there are non-metals. What have the properties of non-metal? Non-metal has properties are they accept electron. They accept electron. They have high ionization enthalpy. These properties are looks like a something new. I will discuss about only. I am talking about these properties because basically this chapter is all about these basic properties. They are important properties. Okay. So these were the classification of all elements. If we will talk about this particular section, they all are metal. They are all metal. But in first row, you will see that is lanthanide. The all metals are radioactive. You know about radioactive? Radioactive are those particular metal. If they are kept in the dark, they will show some light. Radiation. They show radiation that are known as radioactive metals. So interestingly, we will see in the lanthanide, the all are the metals are radioactive. They show some type of characteristics of light. So on the surface, I think on the basis of my knowledge, I have imparted all the points regarding this particular periodic table. So let's look more thing about this periodic table. Okay, look at it. Actually, now it is the turn of naming of element. Till date, there are 118 elements has been discovered. How many elements are there? At least 118 elements has been discovered till date. 118. They are listed in the periodic table. But if you will see, if you will research a little bit, you will get there are more than 118 elements nowadays. But they are not listed into the periodic table. When the periodic table will be updated by IPSC, actually IPSC is the body which always update in chemistry, physics, whatever the units, the changes takes place, the IC take the decision. When IPSC take the decision, then all there are only 118 elements, 118 elements. It would be 125 elements because every year a scientist comes and he discovered a new element. You can be also the scientist. You can be also a Nobel Prize winner if you discover an element. That particular element will be fall into the particular periodic table. So what I am talking about actually, the name of element are taken as you see here are if we see on the table, the name of this particular element is hydrogen. Okay, this particular element is lithium. Okay, this is sodium, this is potassium, this is rubidium, cesium, and so on. You can name the all of them. But after 100 elements, after the atomic number 100, there is a different naming system, that is IPSC naming. So I will teach you how name that particular elements after the atomic number 100. So you have to learn here some code. Look at it. This is the code. Means if an element has atomic number more than 100, then they are named as IPSC. Look at here: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are some abbreviation which is written as: 0 is known as nil, 1 is known as un. Look at here: 0 is known as nil, 1 is known as un, 2 is known as bi, 3 is as tri, 4 as quad, 5 pent, 6 hex, 7 sept, 8 oct और 9 को यहाँ बोल sorry mistake, 9 is known as in. Look at here, as we know, if we numbering the carbon in IPSC naming, you have learned that first carbon is known as meth, second is eth, probe, then but, pent, hex, 7 को बोलते हैं, sorry, 7 is 7 hept, and 8 is oct, 9 is known, but here look at it, totally different name is, that is in, but you have to remember it because you have to make IPSC. So this is in, this is oct, this is sept, and this is hex, this is pent, quad, tri, bi. If you will remember this, then you can able to write down the IPSC name of elements which have more than 100 atomic number. Okay, let's name. If you have to name the 101 elements, an element whose atomic number is 101, then what would be the name of this? You will name like this. You will name, one is known as un. Look at here. One is known as un. Write un. 0 is known as nil. Write nil. And one again known as un. Write un. And add by your side IAM. Always add IAM. EM. So IAM. Now the name will be unnil unniam. Unnil unniam. So write and pin the comment below that what is the name of 118. Soon. I'm waiting. I'm waiting for your answer. What is the name of that? Who connected with us? Please comment. Put your name in the below. I would like to pronounce your name. Please support, like, share, and comment this particular channel, Vinay Academy. If you will support a little bit, we will put our full potential on this particular platform, and we will give you better, bestest content. Please share, like, subscribe, share with your friend, share with your relatives, and talk to them about this particular channel. We are focusing currently on the chemistry, but slowly as we move forward, we will cover all the topics, means all the subject, whatever it about math, physics, and biology, all the subject as you suggest us in the comment, as you recommend, we will focus on that totally. Okay, so what is the answer? Look at here: 118. 1 means that is un, 1 means that is un, 8 means that oct. Where is 8? 8 is oct. This is oct, and put by your side, that is em. So what will be the name of this particular element? Unoctium. So this is the method of IPSC naming that have more than 100 atomic number. Okay, so it has been asked previous few years in NEET and JEE exam, and that always comes into a matching form. Okay, so let's look more. So we have already discussed about that periodic table is divided into the four blocks, that is S block, P block, D block, and F block. All block I have discussed already. You have seen. If there is confusion, there is problem, you can comment, you can ask. Your query is always on top. Okay, we will consider is on top. We'll discuss this first. So look at here, S block elements. We have already discussed that in group 1 there is alkali matter. General electronic confusion are there. The last electron goes into the balance, in last electron goes into the S subshell, so they are kept into the S block. The second group is known as alkaline earth metal, that is group 2. The last electron goes into S, that means it goes into S block, and there is only 2 electron in balance cell subshell, so its oxidation state is +2, and there is 1 electron, so it has oxidation state of +1. These are the elements. You can learn by a mnemonic. There is a little bit in Hindi, so try to learn it. That is Helena की रब से फरियाद. This is बेटा मांगे कार स्कूटर बाप राजी. These are the mnemonic in Hindi. You can make by your own. There is not hard and fast rule that if I am telling that learn it. If you are not understanding, then you can discard it. You can make by your own. Whatever you can make that beryllium, whatever I can make, but I'll try it. I will make it and I'll serve you. Okay, these are the S block elements. You have read all about this. Okay, now next one. It was some property we will discuss about in next lecture, and that property are the most important points and topics of this chapter. We will discuss about. We'll do question of NEET and JEE also. Whatever your exam, you will always see the question are asking on these particular properties, characteristics. So we will discuss it later. These are the elements of P block. P block elements, look at here. I have already discussed about this is 0 group, this is 13 group, this is 14, 15, 16 and 17. These all are mostly there are non-metals. Some metals also are there, but mostly they are all non-metal. And these groups are noble gases, they don't react. These are halogen family, they are most reactive. Okay. So already we have discussed about these P block and F block. F block, actually in class 12 there is a chapter which is known as D and F block. D and F block are kept as separate chapter because all the properties and their characteristics are so different, so wide that we cannot discuss in this particular chapter. So they are kept in a separate chapter. So we will discuss about D and F block in that particular chapter. So don't worry, don't take any tension, any problem that how we did it cover D and F block. So there are only the classification and some properties. So today we are reached on the chemical properties. We have discussed the classification, the position, and the some IPSC name of element after 100 elements. The atomic number of element 100, more than 100 atomic number. So I think it is a good lecture of today. I have discussed about. Now it is the turn to finish the lecture, and I'm again and again requesting your recommendation will be on the top of my. If you will recommend anything, if there is any query of yours, that would be goodness for us. So please comment and like, subscribe, share this particular Vinay Academy that we could do better in future. We will invite more teachers on this particular platform. Okay. So very good evening, very good morning, a very good night, whenever you are watching from anywhere, from any corner of the world. And thank you. Hope and I pray from the God for your wellness, your goodness. Okay, thank you. Thanks for stay with me till longer. So let's meet in the next lecture with fresh concept and fresh topic. Thank you.